Dear student, Assalamu alaikum and welcome to e-learning Al Noor International School, grade 11 chemistry course. I'm your chemistry teacher Faraz Anjum. Today we will continue chapter number 19, acid, base and salt, lesson number 2, hydrogen ions and acidity. In this week lesson we will cover textbook page number 658 till 662. So please open your page 658. In this lesson, our main objectives are classify a solution as neutral, acidic, basic by using pH and identify two methods that are used to measure the pH. So let's start calculating the H from pH. And if you remember, last week we did the pH, how to calculate the pH, okay? So you can calculate the hydrogen ion concentration of a solution if you know the pH. So how we can do it? So look here. If the pH is an integer, it is easy to find H positive ion. For a pH of 9.0, H positive ion concentration is equal to 1 times 10 power negative 9 molar. Most pH values are not the whole number. When the pH value is not the whole number, you will need to calculate to a calculator with an antilog 10 power x function to get an accurate value of the hydrogen ion concentration. Have a calculator. So calculating H positive ion from pH. The pH of an unknown solution is 6.35. What is the hydrogen ion concentration of the solution? This is your question. So let's start. What is given? pH of solution, which is 6.35, and asking H plus ion concentration in molarity. Okay, this concentration. How you do this? You know the formula of pH is equal to negative log H positive ion. Okay, you can write like this: negative log H positive ion is equal to pH. Okay, and pH value how much? 6.35. So put the value of pH here. So the equation will be like this. After that, you need only H plus ion concentration. So log here going this way become anti-log. Log become anti-log this side. Okay. So remove the log, take from other side, it become anti-log. So H positive ion is equal to anti-log of negative 6.35. So put into the calculator, press anti-log, negative 6.35. It gives you 4.5 times 10 power negative 7. Okay, students. Now, after getting this, first of all, how you will get the anti-log in the calculator? So press shift and log button if you don't have the prominent anti-log. So how you do this? Shift, then log. After log, write the minus or negative sign with 6.35 and press equal. Then you will get the answer. So the pH is between 6 and 7. So the hydrogen ion concentration must be between 1 times 10 power negative 6 molar and 1.1 times 10 power negative 7 molar. The answer is rounded off to two significant figure because pH has measured to 2 decimal places. Okay, now calculating the pH from OH. Now another one. Okay, not H, OH now. So if you know the OH of the solution, you can find its pH. You can use the ionic product constant to determine the H positive for a known OH negative. Then you use H positive ion to calculate the pH. How? Here. So the question is, what is the pH of a solution if OH is equal to 4.0 times 10 power negative 11 molar? So you can see here OH is given. You know the Kw constant we discussed in the last time, this one, that 1.0 times 10 power negative 14. pH is wide. So what you do? Kw is equal to OH negative times H positive. Okay, you need H. Okay, OH is given. So what to do? Okay, to calculate this, simple, substitute the value of Kw and OH to find H positive ion concentration. So H positive ion is equal to Kw, and Kw value is 1.0 times 10 power negative 14 over what is the OH value of OH is given in the question, 4.0 times 10 power negative 11. When you divide, it gives you 0.25 times 10 power negative 3. Remember, decimal must be after one digit. So 2.5 times 10 power negative 4. Okay. Molar. This you got the concentration of H positive ion. When you got the concentration, now next to use the equation to find the pH. Substitute the value of H positive ion. Now what you find in the previous slide, 2.5 times 10 power negative 4. So put the value here for H. Okay, and then in the calculator, use the calculator to find the log. So type negative in the calculator, press log button, and then type the value 2.5 times 10 power 4. You will get 3.60025. Overall, you will get the negative negative going to be cancelled and 3.60. Okay, so the pH of the solution will be 3.60. Okay, a solution in which the OH is less than 1 times 10 power negative 7 is acidic because H positive ion is greater than 1 times 10 power negative 7 molar. The hydrogen ion concentration in between 1 times 10 power negative 3 molar and 1 times 10 power negative 4 molar. So thus the pH should be between 3 and 4, and this is correct. Why do we use the pH scale to express the hydrogen ion concentration? Answer: it is more convenient and practical to use the pH scale. Expressing hydrogen ion concentration in molarity take up a lot of space and it is not easy to work with. Now measuring the pH. What are two methods that are used to measure the pH? Either acid-base indicator or pH meter can be used to measure the pH. Okay students, now let's talk about acid-base indicators. An indicator is an acid or base that associate in a known pH range. Indicator works because their acid form and the base form have different colors in solution. Suppose this is indicator going to break in H positive ion and base form. Okay, so acid form become base form like this. Okay, so the acid form of indicator is dominant at low pH and high H positive ion concentration, and base form is dominant at high pH and high OH concentration. The change from dominating acid form to dominating base form occurs within a narrow range of about 2 pH unit. At all pH value below the range, you would see only the color of the acid form. At all pH value above the range, you would see only the color of the base form. Now you can see here now. Many indicators need to span the entire pH spectrum. The most common indicator is phenolphthalein. So you can see where it is in this range. So pH is supposed to be 8 till 10 and the color is pink. Okay, so you can see in the this is base form. Okay, so in the base it gives you the pink color. Okay, and here thymol blue, most common for acidic form. Okay, also methyl red. Okay, it gives the orange color here. So there are the different acid base indicators. So an indicator strip is a piece of paper or plastic that has been soaked in an indicator and then dried. The paper is dipped into an unknown solution. The color that result is compared with a color chart to measure the pH. Some indicator paper has absorbed multiple indicators. The colors that result will cover a wide range of the pH value. So means what is it? That take the pH paper, put into the acid or base, change the color match to given chart, and then there is a value you can see, and then this is the value of pH. Okay, now acid base indicator. Soil pH can affect how plant develop. In acidic soil, hydrangea produce blue flower, and in basic soil, hydrangea produce pink flower. Okay, so what is hydrangea? Like a shrub or creeping plant. A pH meter is used to make the rapid continuous measurement of pH. The measurement of pH obtained with a pH meter are typically accurate to within 0.01 pH unit of the true pH. If the pH meter is connected to a computer or chart recorder, the user will have a record of the pH changes. So the most common and most accurate in the lab pH meter, we are using the pH meter for the accuracy of pH. The pH meter can be easier to use than the liquid indicator or indicator strip. The pH reading is visible in the display window on the meter. Here you can see the color of the cloudness of solution do not affect the accuracy of the pH value obtained. So here is taking the soil pH and then indicate here how much is it. Okay, student, now this is the end of 19.2. Thank you so much, and please, if you have any doubt or question, you can ask me in the comment day 1 discussion or day 2 discussion. And please try to complete yourself the section assessment of 19.2 in textbook as well as workbook 19.2. Thank you.